In the previous section, you studied limits such as limit x approaches 1, x squared minus 1 over x minus 1. You discovered that direct substitution could produce an indeterminate form 0 over 0. In mathematics, an expression is indeterminate if it is not precisely defined. There are 7 indeterminate forms: 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, 0 to the power of 0, infinity to the power of 0, and 1 to the power of infinity. L'Hopital's rule can help us calculate a limit involving indeterminate form. But in the syllabus of Calculus 1, we will not discuss the L'Hopital rule. In the syllabus of Calculus 1, we only focus on the indeterminate form 0 over 0 and infinity over infinity, right? In a previous video, we discussed how to evaluate a limit for an indeterminate form 0 over 0. So, in this video, we will discuss the limits for indeterminate form infinity over infinity, right? Evaluating limit x approaches infinity, fx over gx equals to infinity over infinity. In this section, we will discuss limits at infinity of quotients involving polynomials and radicals. First, if fx and gx are polynomials, and second, if fx and or gx are radicals, right? Let's start off the examples with one that will lead us to a nice idea that we'll use on a regular basis about limits at infinity for polynomials. Now, we look at limit x approaches infinity to x to the power of 4 minus x cubed plus 3x squared minus 1. Our first thought here is probably to just plug infinity into the polynomial and evaluate each term to determine the value of the limit. It is pretty simple to see what each term will do in the limit, and so this seems like an obvious step, especially since we have been doing that for other limits in previous sections. So, let's see what we get if we do that. As x approaches infinity, then x to a power can only get larger, and the coefficient on each term, the first and the third, will only make the term even larger. So, if you look at what each term is doing in the limit, we get the following. If we just plug infinity into the polynomial and evaluate each term, we will get this. 2x to the power of 4 equals to infinity minus x cubed equals to infinity, and then plus 3x squared equals to infinity, and then minus 1, right? Then we will get infinity minus infinity equals to 0, and then plus infinity minus 1, and infinity minus 1 equals to infinity. However, in this case, we had been wrong. This is one of those indefinite forms, which is infinity minus infinity, that we first started seeing in a previous slide. Infinity minus infinity is not equal to 0, because this infinity minus this infinity are not the same value, right? So, we need a way to get around this problem. So, to solve limit x approaches infinity to x to the power of 4 minus x cubed plus 3x squared minus 1, what we will do here is factor the largest power of x out of the whole polynomial. The correct method is like this. We write this limit equals to limit x approaches infinity x to the power of 4 times in bracket 2 minus 1 over x plus 3 over x squared minus 1 over x to the power of 4. From here, factor the largest power of x out of the whole polynomial means we factorize x to the power of 4, right? Which is the largest powers of x, right? Let us check whether we factorize the correct way. If we expand this, we should get the original function, right? X to the power of 4 times 2. We get back 2x to the power of 4. X to the power of 4 times negative 1 over x. We get back minus x cubed. And then x to the power of 4 times positive 3 over x squared. We get back plus 3x squared. And then x to the power of 4 times negative 1 over x to the power of 4. We get back minus 1, right? From the previous video, we have discussed limit x approaches infinity 1 over x equals to 0. This is true, okay? Limit x approaches infinity 1 over x squared is also equals to 0. Limit x approaches infinity 1 over x cubed is also equals to 0 and etc. Right? Let's say if we have any constant in numerator here, okay? And then divide by x cubed here, okay? We still get equals to 0 if we evaluate limit x at infinity. Alright? Right, so from here, limit x approaches infinity 1 over x will approach 0. Limit x approaches infinity 3 over x squared also will approach 0. Limit x approaches infinity 1 over x to the power of 4 approaches 0, right? Alright, since we get 0 here, so we can write equals to limit x approaches infinity 2 times x to the power of 4, right? And then from the previous video, if we have limit x approaches infinity to x, we will get approaches infinity. Limit x approaches infinity 3x squared will approaches infinity. Limit x approaches infinity x to the power of 4 will approaches infinity if we have x to the power of positive here, right? Right, so from here, okay, we will get the answer infinity because limit x approaches infinity to x to the power of 4 will approaches infinity, right? Or, since we get 0 for this term, we also can solve this limit like this. We just consider the term containing highest power of x. So we can write equals to limit x approaches infinity to x to the power of 4. And then from here, when we solve this limit, it will approaches infinity, right? This is shortcut method. But please be careful. This method valid for limits at infinity only, right? So this method is correct and this method is also correct. If we have limit x approaches infinity, we also can use shortcut method, right? Coming up next, limits at infinity for a rational function. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.